Okay, in this video we're going to talk about finding the nth root of a complex number. This is from the topic of complex numbers, and the method that we are going to use here is called the spacing of nth roots, right? So you will be given a complex number raised to some powers, and then you will be asked to find the roots. So you'll be asked to find nth roots, for example the second root or the third root or fourth root or fifth root or so on. So how do we do that? We're going to do that with one example. Example number 1. For the complex number z power 4 is equal to minus 16, find the fourth roots. Okay, so we have a complex number raised to power 4 is equal to minus 16. So we have to find the four roots of this complex number. Now to do this we have to first list down the information, right? So the roots that we have to find here is n is equal to 4, right? We are talking about z power 4. Okay, and we know our complex number z power 4 is equal to minus 16, right? If you write this in standard form, this will be z power 4 is equal to minus 16 plus 0i, because this should be written in the form of a plus bi, right? So from here we can list that our real of z is equal to minus 16, right? And the imaginary part of our z is equal to 0. We do not have an imaginary part of this. Okay, so we have to evaluate the fourth power or the fourth roots. Okay, and these are our information. Now to do this, it's very good to draw the diagram first. Okay, now if I draw the diagram in an Argand diagram, this will look something like this. Okay, this side will have our real of z, and we have imaginary of z, right? So we have minus 16 and 0. So minus 16 will be this side towards the left, so we'll have a minus 16 here. Okay, and we do not have a imaginary part. The imaginary part is 0, so we do not have to move anywhere else. Okay, so this is the point where we arrive. Now if we look at the theta or the argument of this complex number, we'll be taking from the positive real axis, so we have to go this way, okay, and arrive to that point. Now we can see that we have gone 180 degrees, right? This is just a straight line. Angle on a straight line is 180, and it is in the second quadrant. Okay, so this first one is 90, this another 90 makes it 180. So that means the argument for this complex number is 180 degrees. Okay, now let's find our value of r, right? Let's find value of r. So we have to find r. Okay, so r, like I said in the previous video, that we're going to find r using the calculator method. Okay, so we can use calculator method here. We'll use calculator method. We are going to find r. Now remember, r here will be r power 4, right? Whatever value of r we're going to get will be to the power 4, because we have z power 4 here, right? We have z power 4. So whatever r that we are going to get, it will be also raised to the fourth power. So r power 4 will be basically POL, this is the calculator method, is open bracket minus 16 comma 0. So this is the real, this is the imaginary, right? Now when we do that, we get POL minus 16 comma 0. We get our answer as 16. So we get 16 here, right? Now this is r power 4. Remember, our goal is to get r, not r power 4. So we have to take the 4th root of this, right? So when we take 4th root of that, our value of r comes to 2. The 4th root of 16 is 2. Now to find the argument, right? To find the argument, number 2, find argument of z, right? We also use the calculator method. We said if we do RCL tangent, we get the value of theta. So to that result, if we press RCL tangent, we get the value of theta, right? And the value of theta is 180 degrees. Now this is our argument of z, and from the diagram here we have seen that it comes to 180. Okay, now the third step is to find the angle spacing. We have to find the angle spacing, and how is that done? We will do 360 divided by n. 360 divided by n. So 360 degrees divided by our value of n is equal to 4, right? 4 is coming from here, right? So 360 divided by 4 is basically 90 degrees. Okay, so this is our angle spacing, right? Let's call that AS, angle spacing, right? AS. Okay, let's move on. Number 4. Now fourth step is we have to find the smallest angle. Okay, so we have to find the smallest angle. So how will we do this? We will take our argument, the argument of z, right, and we will divide by n. Now argument of z we have found here, it was 180 degrees, so it will be 180 degrees divided by 4, and 180 divided by 4 is 45 degrees. So this is our smallest angle, so we'll say SA, smallest angle, right? Now we are in a position to write our 4 roots, right? So our first angle will be basically that 45 degrees, the smallest one. The second angle will be 45 degrees plus our angle spacing, right? 45 degrees plus angle spacing. So we'll write here AS. So this will be 45 plus 90 degrees. Okay, now 45 plus 90 is equal to 135. This is equal to 135, right? This is our second angle. This is our first, this is our second. Now moving on to the third one. The third angle will be basically this angle, 135, plus again our angle spacing, because this is the spaces that we have between the angles. So plus another 90 degrees. So this will be 225 degrees, right? So we have found our first, our second, and our third angle. We have to find total of 4 angles, right? Because we have n is equal to 4. So the fourth one will be basically this angle, 225 degrees, plus the angle spacing again, 90 degrees, plus 90 degrees, and this is equal to 315. Okay, so we have found our angles, angle 1, 2, 3 and 4. Now we can write our answer. So our answer will be written as the roots in polar form are. Now our answer will be in the form of r cis theta, right? R cis theta. So the first angle was 45, and the value of our r that we found is equal to 2. So the first one will be 2 cis, the value of theta is 45, the first one. So 2 cis 45 degrees. The second angle will be 2, because our r is still 2, cis, second angle was 135, so 135 degrees. The third angle will be 2 cis, third one is 225, and the fourth one is 315, 2 cis 315 degrees. So these are our 4 roots in polar form, right? We can write here the 4 roots. The 4 roots in polar form are all of this. Okay, and this method is known as the angle spacing method, right? You have another method known as the formula method. The formula method, but that one is a bit different from this one. This one is a much easier one. Okay.